America is known for its large and expansive bridges. For example, the Royal Gorge Bridge is 955 feet long, the United States' tallest bridge. The Royal Gorge Bridge, built in 1929, is the tallest in the nation, soaring over 1,000 feet above the Arkansas River. When compared to the highest bridges in the world, the 955-foot bridge comes in 7th place. So where are the biggest and tallest bridges in the world, if not the US? Well, the answer is China. Hello, and welcome to the channel. Today we're going to talk about how the mega bridges that China is constructing are shocking American scientists. Americans are big fans of large and towering constructions. They're known for monumental buildings, especially their bridges. Who doesn't know about the beauty of San Francisco's Golden Gate Bridge in California? The 1-mile or 1.6-kilometer wide Golden Gate Strait that connects San Francisco Bay and the Pacific Ocean is crossed by the Golden Gate Bridge. A suspension bridge. Well, Chinese engineers have just asked their American opposite numbers to hold their beer. The engineering feats of the bridges that China boasts will shock you just as much as it has shaken American engineers. Bridges have been a way to make sure that human expansion continues to newer horizons. They've helped us access rugged terrains and across challenging water bodies. Historians claim that Arcadico Bridge, the oldest bridge in the world, was built approximately between BC 1300 to 1190. It is still found in Argolis, Greece, built by Mycenaean Greeks and spread across 72 feet. The Mycenaeans were native Greeks who were probably inspired to create a more complex socio-political culture by their interactions with Minoan Crete, as well as other Mediterranean civilizations. The most well-known location was Mycenae, after which this era's culture was named. Pylos, Tyrants, Mydia and the Peloponnese, Orchomenos, Thebes, Athens in central Greece, and Iolcos in Thessaly were some of the other centers of power that rose. Additionally, Mycenaean and Mycenaean-influenced settlements were found in Epirus, Macedonia, and Aegean Sea Islands along Asia Minor's southwest coast, in the Levant, Cyprus, and Italy. Although the bridges are not made out of stones, and well, 72 feet is not even the length of some of the basic bridges in the world. In fact, bridges are now used for more complex functions and not just crossing an obstacle. China has been one of the fastest countries to grow in terms of development. As a country, they have achieved some remarkable feats, and they have some astounding engineering feats when you gaze at the bridges they've constructed. Many countries will look at it with awe and envy, especially in the United States. Let's talk about a few of the bridges that will put their American counterparts to shame. Green Juice Bridge. The first single-tower, single-span suspension bridge in the world makes traveling through China's picturesque Yunnan province a little bit easier and more exciting. Lujijiang Bridge spans a river valley of 798 meters. It's not very high in comparison to some of the other longest bridges in the world, yet the project has become known as an engineering wonder due to its complexity. The bridge rises from tunnels that jut from steep mountain slopes on either side of the valley above Lujijiang, which is translated as Green Juice River. It is the first single-tower, single-span suspension bridge in the world, and it was constructed into a rocky V-shaped valley. It is supported at both ends by cables. Because there are no more columns, it has a dramatic, defiant appearance. The single span of the bridge is 780 meters between the two supports. Additionally, according to officials, it boasts the steepest tunnel anchorage in the entire world, which is tilted at 54 degrees. The 156-meter-high tower, the bridge approach slab on one end of the structure, and the tunnel anchorage on the other end of the structure are all built upon steep slopes because of the rocky terrain in the vicinity. Shishui River Bridge. Local authorities intend to construct a new bridge connecting the two roadways in order to boost economic development in the Chinese provinces of Sichuan and Guizhou, as well as offer a dependable connection between the Guizhou-Jiangxi-gu and Sichuan-Zhugu expressways. The 2,009-meter-long Shishui River Bridge, which would cost CNY 1.7 billion, will span the river. For the project's design, production, and construction, Sichuan Road and Bridge is in charge. The complex topography and geology of the meandering, hilly site included a cliff on the Sichuan side, a maximum elevation of 350 meters, collapse zones, and rocky and karst areas that posed a danger to the project team. Therefore, they need a plan that offers a sturdy framework for structural support across the large valley above the river. Consequently, a dual tower and single-span suspension construction would be necessary for the bridge's 1,200-meter portion. Rocky and karst sections that pose the risk to the project team. Sichuan Road and Bridge understood they required a more adaptable digital workflow as the concept of the Shishui River Bridge was becoming more complex in order to guarantee an accurate design, enhance team communication, and prevent errors and conflicts. With the limited usage of heavy equipment and the difficulty in building an access road, this project was one of the most difficult they had undertaken throughout the years. The team had to figure out how to build the primary bridge deck as a truss off-site and transport it to the gorge, as well as how to construct a system of 158 cables to hold the bridge deck. As normal, bridge construction techniques couldn't be used because of this. As a result, conventional 2D design techniques were inadequate. Sichuan Road and Bridge discovered the solution to their design problems using the BIM technique and 3D visualization. They established a solid footprint for the bridge towers using context capture, microstation, and open bridge modeler. Then they used ProStructures to optimize the bridge design and make sure that all 158 cable claps were positioned and oriented correctly. Last but not least, they used Lumen RT and MicroStation to model the construction process in order to figure out how to protect employees and use as little land as possible when building, particularly when hoisting steel truss components into place. Yangbaoshan Bridge. Ziyang-Huangping Expressway's main line is 120.6 kilometers long and runs the Guiyang City to Yucai Expressway. Among them, the steel truss girder suspension bridge has a major span of 650 meters, and the modern control Yangbaoshan Super Bridge has an overall length of 1,112 meters. It adapts two-way, 6-lane highway standards, making it the very first suspension bridge in Guizhou Province. The project's key technological achievement is the installation of the main cable aerial spinning, a first for China. The primary cable is 1,113 meters long and has 4 back cables in addition to 72 through-length strands. It weighs close to 4,600 tons and is made up of 24,128 high-strength galvanized steel wires. The aerial spinning method, which differs from the traditional ready-made parallel cable strand production procedure, uses traction equipment to reciprocate and draw high-strength galvanized steel wire to create parallel steel wire strands on site. The effective implementation of this technology not only closes the technological deficit in the country, but also serves as a benchmark for the industry as it develops technical standards for the primary way of spinning cable aerials. The most practical expressway connecting Guiyang and the Yangtze River Delta Economic Zone is the Guiyang-Huangping Expressway, which will significantly advance the regional economy and social development. Hong Kong-Zhuhai-Macau Bridge. The inauguration of the 29.6-kilometer Hong Kong-Zhuhai-Macau Bridge took place in October 2018. It's the longest sea bridge in the world, measuring 55 kilometers in total length, including connecting highways. It links the western part of Hong Kong to Zhuhai, a city in the Guangdong region, and Macau. The bridge cuts the distance between Hong Kong, Macau, and Zhuhai in half and is anticipated to boost the economies of all three areas. Beginning in March 2009, the main bridge's preliminary design was created. Beginning in December 2009 and ending in February 2018, the project was finished. The project had a total cost of CNY 120 billion or $17.3 billion, of which 87 million was approved for funding for site assessment and preliminary design and 47 million for early pre-construction work. The project involved building the Hong Kong Link Road, the Hong Kong Boundary Crossing Facilities, and the HKZMB. It also includes the construction of supporting infrastructures, such as street lighting, traffic control, surveillance systems, landscaping, and drainage work. The main bridge of the HKZMB spans the Pearl River from east to west over a distance of 29.6 kilometers. The bridge has a double 3-track carriageway and is constructed as a bridge-cum-tunnel. On 2 official islands that were built to the east and west of Hong Kong's Special Administration Region, it lands. Construction of buildings for passenger clearance, and the installation of screening kiosks for private vehicles and buses. There are also frontline offices for government agencies like immigration and exercise in the boundary crossing facilities. Road networks, public transportation switchover areas, and drop-off and pickup areas have all been planned for. It is positioned in the shape of a 9.3-kilometer long sea viaduct that is made up of several arches and that are supported by piers. A vehicle speed of 100 kilometers per hour is supported by the connecting roads design. Beginning in 2011, work on it was finished by the end of 2017. With that, we've come to an end. See you next time. Goodbye.